Good morning, everybody. Hello, everybody. We are slowly starting our morning session, our webinar about Matrox portfolio. So, if there is anybody there, please let me know if you hear me, if you see my presentation, and maybe even my camera. So, I will be really glad to have some feedback. Okay, so let's not postpone it. Let's start it slowly. So today will be not only me speaking, however, the introduction will be done by myself. I'm just checking, seeing you. Okay, I see first feedback. So thank you for the feedback. Let's go with it. So my name is Adam Kaczmarek, and I am from Poland. And today, together with Katrin, which I will introduce to you in a second, we will talk about Matrox portfolio, Matrox video portfolio to be more precise. But first, before we start talk in depth about the Matrox, let me introduce you slowly to our portfolio and how Matrox fits it. So first, you saw probably our website. It's full of different brands. There is a lot of them. But what we are seeing right now these days, it's about growing number of projects in terms of AV over IP. And in terms of the AV over IP brands, we again have a lot of them in our portfolio. Uh, In terms of the basic solution about AV over IP, we have very basic setups like encoders, decoders, one-to-many, many-to-one. We can do everything with our basic solutions coming from Infobit, some PureLink, Cypress, or most of the Kramer devices. If we need to go for a little bit advanced solutions with, some basic video wall functionalities, some KVM on board. We have Cypress, we have Kramer, and most importantly, it's a Zivi here. However, what we lacked this year, on the beginning of this year, was, I call it top tier solutions. Solutions which brings very advanced functionalities, adaptation of the most recent codecs to the table. That's why we introduced Matrox to fill this need for very professional, like a turbo super professional AV over IP, but not only solutions. So that is our current portfolio. But thanks to the Matrox, we again added to the technologies support for example, IPMX, which I'm sure Katrin will tell you more about later on. Very advanced multi-channel AV over IP, which also brings us a lot of different potential projects. So that's why Matrox is here to fill this gap with super professional, not only AV over IP, which you will see, but this is one of the most important parts of our portfolio these days. So guys, let's cooperate and let's start to talk about Matrox. A few remarks before I start. So this is interactive session. So you have access to the questions, answer and questions function of the Zoom webinars. So don't afraid to ask questions. Just type them, raise your hand, type the question, and we will try to immediately. I will be the admin of this session. The most of the talking will be done by Katrin. However, if you will have question, I will try to nicely interrupt her and ask the questions so we can both try to answer you. During the webinar, I will also launch some short questionnaires so we can get some basic feedback from you. So don't afraid. Also, just click on proper answers and yeah, that's all. Let's start the key part of our presentation. I will now stop sharing and hopefully, yes, we have her. Good morning, Katrin.
Good morning, everyone. Very nice to meet you and welcome to icy, rainy Munich, at least virtually. Hopefully the weather is much nicer in wherever you are at the moment. And we are happy to welcome you today in the Matrox Video Lab and do a little dive into the Matrox portfolio, showing you like the wide range of solutions you can deliver with our products. And typically where I am right now, this is my starting point. Looking at you in the live stream camera, we are already using a Matrox product to bring the live stream to you, our Mavex, which will be get, of course, a short 5 minutes as well in today's tour. But I would like to start talking about Matrox main business control room solutions, mission critical control room solutions in whatever industry you could think of. And very often when we think about control room, we think about an operator workstation as well as a video wall. And that combination is very often popular to share different information, to show different camera feeds. Like, for example, you see the webcam camera also on the video wall as such, but we also have KVM integration in that sense. And we like to call it an IP ecosystem for control room solutions. And we are starting with the fact that we have, of course, always an operator that needs to operate certain processes. So, and in modern control rooms, for ergonomic reasons, for security reasons, KVM solutions are very popular. KVM extension, to be specific, that allow us to actually put the operator workstation into a server room, locked, air-conditioned and secure, and then extend it with very low latency to an operator desk where I have a keyboard and mouse. And I would like to bring your focus to the workstation here, that maybe we can also zoom in a little bit. Yes, perfect.
So, Katrin, before
Yes.
we will dive into the portfolio more deeply, I would like to ask a question to our audience about Matrox in general. How familiar are they with your products? So I launched a short questionnaire right now. So let's gather some feedback. You can start talking. You can still talk, and then I will bring the results to the screen.
Perfect. Okay. All right. We are very efficient today in this quick hour. Yes. So continuing on KVM solutions here, Matrox carries at the moment two different brands. One is a multi-channel video brand, highly integrated, using high compression mechanisms to actually populate many video streams, USB and audio at the same time over a 1 gigabit network infrastructure. So we are using a very popular codec called H.264 in our XTO3 brand. And this is what you currently see with these two boxes outside here. And the channel density we even have tried to provide here with our aggregator tile view, where you may understand we are actually collecting 4 different computers and we can seamlessly move the mouse across all of them. Yeah, so XTO3 stands for multi-channel, meaning 4 Full HD at the same time, 2 4K 30 at the same time, or 1 4K 60 stream at the same time over a 1 gigabit network. A little bit opposite to XTO3 as a multi-channel device, we have our new KVM called AVio2. In AVio2, however, there's a little extra element worth to mention, is that it is the world's first KVM based on open standards. And open standards in particularly context of media transport over IP. What do I mean with media? It's video, audio, metadata, and USB as such. So this is the transport that we would like to describe. That, of course, when we particularly speak about video, can do in 2 different things. Compressed, untouched, which is very important for certain use cases. So no latency, and definitely the raw material send it across the network. or compressed, like we do with X-Studio 3 using H.264. But in open standards for media transport, we now have the choice to pick and choose which transport mechanism we want to choose, particularly for the video. And this is what our AVO2 brings to the market, being the first IPMX and SMPTE 2110 ready KVM, which is now the name of the open standards that also Adam briefly mentioned in his presentation, which is a very big focus of Matrox and other companies working in the AVoIP landscape. So our AVO2 as a single channel KVM is also part of our setting, and we can freely switch between the two different KVMs depending on your need to show you a little bit similarities, differences. And of course, if you are interested and have a project for KVM, we can also really do a deeper dive and explain the infrastructure, our layout here, our schematic, as well as the user interfaces that we and the control mechanisms that we provide to those KVMs. So you may wonder how we do that with a single keyboard and mouse, that we can operate 3 different receivers, 2 X-Studios, 1 AVO. So there is a little utility that we use as a helper. This is the Matrox KM Link. And Matrox KM Link is a simple USB switch. It collects up to 4 USB devices into one device, so that we can actually, instead of having 3 different sets of keyboard and mice, we can operate all the 3 receivers with the same keyboard and mouse, which is not related to this multi-view that you see here. So that already works inside the KVM itself. But now we also give you, if you need to add more devices that you need to operate at the same time, we give you this physical USB switch. Yeah. So coming back to the correlation between KVM and the video wall. So as we move also now to the video wall as a next segment, you realize my KVM streams are in the network. So instead of using HDMI splitter or a matrix or something physical, I can now populate and repopulate my KVM streams to the video wall as well. So and this is why I'm changing a little bit my position and move to our demo rack. The demo rack, just to complete maybe to what we have talked about here in the context of the KVM, we have, of course, here our PCs, and you may now realize, if you wondered what is the A1, the C, D, E, and F about, we actually labeled the different computers that we have in our demo rack, so we can identify the computer source. Then we have connected the different KVM senders to it, the X-Studio 3 down here, or the AVO2 up here to those systems. Yeah, and then we just have a generic network infrastructure. In our case, it's a Cisco switch, because X-Studio 3 in particularly uses high compression and fits very nice in 1 gigabit AVoIP infrastructures, and the AVO2 with the use of compression, what we do here in our workflow as well. But we wanted to speak about the video wall, which is our nice 2x2 4K display wall you see here on the wall. And Matrox currently has 2 mechanisms of operating video walls. One, I call it a little bit traditional and classical way, is using computers. Computers means it's a Windows PC. Yes, and Nico shows you a little bit how it looks like around here in our demo rack. So we are using output cards. Some people call it graphic cards, where Matrox has been very popular for many years. So we have output cards based on Windows drivers, as well as so-called capture cards, so that the output actually can give us 4, 8, 12, 16, or how many displays you actually would like to have as outputs in 4K. And our current Luma series can even support up to 2 8K resolutions, yeah, besides the 4K. And our latest addition to the Luma is even an octal card that gives you 4 times 4K and 4 times 8K and 8 times 4K. Numbers are sometimes a bit tricky to not mix up. Yeah, so this is what we call Mura-based capture and output cards, Windows-based video controller type of concept. And as a little utility, as part of that family, we also have a software that lets us create this preset that you see here, because this, as you realize, these are the streams coming from the KVM. Yeah, so and they are just positioned as a 2x2 on our video wall. And in order to create this preset, we have the utility called Mura Control for Windows. The second and pretty interesting and even I would say more modern way of doing video walls is a new concept called distributed video wall. And in that context, we are starting talking about little appliances, and maybe I can briefly show you one in the camera. So this is, I sometimes say, a high performance video wall controller in my handbag size. Yeah, because this is a video wall device that outputs 4x 4K on HDMI. It receives only IP streams. So that's no problem for us because the KVM streams are already in the network as one examples, or IP cameras, CCTV cameras are already in the network. So we just collect these streams into these little devices, connect displays to it, and show the content with a nice utility called Mura Control for Web. And this is what I would like to briefly chime in the presentation. So this is the only user interface I would like to definitely show you, because it is so simple and so intuitive. And it comes actually free of charge with those utilities. So Mura Control for Web, as you see here, connects to this little IP node that I showed you before. So it actually, when you connect it to your laptop, the screens show the IP address, you enter it in your browser, and from here you start first configuring your video wall, and secondly, configuring your layouts. As you may see, we already have a couple of layouts. So currently we see the XDO IP feeds, but we also have a layout for the AVio KVM where we can show the KVM feeds, or we spoke about IP cameras that we can bring up. So here's, of course, a little network handshake and a gremlin as part of the process, part of it. But also very interesting and becoming more and more popular is to just use browser-based applications. So, and when you look into network operation centers and monitoring centers, they typically use either Chromium-based browser solutions. And even with just those browsers, you can create different presets, and you can enable even people to dive into the browser and change web pages, etc., etc. That's a very...
Katrin, I have one question.
Yes, go ahead, please.
How it works with non-standard output resolution? Like, are we able to connect it to LED wall?
Absolutely. The units work based on EDID. And if the EDID is not there, Matrox can create a custom EDID for you.
Okay, so we can use it also with the LED video walls, which are, crazy popular these days. They are rising a lot. There is a lot of new projects about it. So
exactly. Yes,
fit.
I totally agree, and it definitely fits. Yeah. And as we speak about LEDs, we also speak about content synchronization. There is a little element to our particular setup here in the room, is we are actually, for our 2x2 wall, using two of those appliances. And Nico shows you briefly how it's mounted behind and how small they are. Yeah, and I will quickly switch to a video that actually spans across multiple appliances, because as you say, LED walls, for example, sometimes it looks like we have a little gremlin here. And let's do quickly something else and start the source again and bring the video back, because this is very often a question. If people would like to go bigger than what we have currently, how does it actually synchronize? And the nice thing is, we used to really worry about Windows-based systems where, when we worked with multiple GPUs, we basically had problems that, Windows operating systems would not properly detect it. And the GPU synchronization was a little bit messed up by Windows. We no longer have this problem now with the DVW. Yeah, as you see, we are running here a single stretched video across 2 different appliances, and we synchronize the content over network. Yeah, and that is makes things much easier than fiddle around with Windows drivers and firmwares and stuff like that, as one example.
Yeah. What are the
Yes.
limitations of those appliances in terms of decoding the signal? How many of it, in which resolution?
Yeah, well, it depends, of course, because the DVW supports H.264, H.265, up to 4K streams. But if you take an average 1080p 60 420 type of stream, we can talk about 17, 18 streams simultaneously.
Okay.
Yeah, and that's quite powerful for just one device. And as mentioned, if you need more processing power, you just add another box. It's not that expensive. I'm sure Adam will be happy to give you a price after the session. So I think it's a very cost-efficient solution that we are offering here. And the interesting part of that one is also now not thinking of the video wall. Yeah, and that is sometimes what I tend to say, like a very flexible AV over IP endpoint, because as you may be familiar with different AV over IP brands and products, typically they are purpose built, and typically if you need to see more streams, it's a fixed preset or it's a picture in picture. So here we can actually freely scale and rearrange according to the wishes of the customer. So it's a very flexible multi-viewer, IP multi-viewer in that sense as well. Yeah, this would be my concluding part of the video wall, the KVM discussion, and so on. If you have no more questions, I would start moving on to IP in general. The other portfolio that Matrox has, which you could see as suppliers into our video wall, for example, or into other workflows. Yes, looks like no questions. Then let's move on.
Yeah, no questions. So give me a second. I see something. I will take it. Can't it decode IPMX? That's the question.
That is a wonderful question. I had hoped for this. Not yet, but it's coming. And we will show you today a little bridge product because you may realize, as I already spoke about the KVM, that we have H.264 and we have IPMX and SMPTE 2110. And we have customers using H.264 a lot and now want to expand here. Do they need to rip out what they have in H.264? No. That's why we actually, let's call it fake it until you make it, or we can have a bridge product that can convert actually between the 2 different protocols, which will maybe also interesting not only in the Matrox bridging concept, but also bridging to NDI as one example. But this will be a later part of the presentation. But very good question, love it.
Okay, let's move forward.
All right, then let's move to the second H.264 based implementation that Matrox has done. And here is our AVoIP / streaming corner. And I like to mention both use cases in the same breath because there is distinct differences to those. Yeah, AVoIP typically means controlled with a control panel, that you have all the endpoints in your helicopter application, etc. While streaming means streaming to somewhere where you don't know the endpoint. Yeah, and with our MAVEX portfolio, Matrox implemented H.264 based on RTSP based streaming. As well as AVoIP, because particularly the MAVEX 6000 and also the MAVEX 7000 series supports multiple protocols compatible with H.264 in the same device. Yeah, particularly Matrox 6000, we speak about RTSP, RTMP, HLS, MPEG-2 transport stream, and RTP stream. So what do these different protocols have certain tasks? Yeah, RTSP is typically used when you have endpoints. Yeah, you have an encoder and a decoder that you would like to see. You would like to define the quality. You would like to have the low latency to do AV over IP signal distribution to start with. But looking at the other protocols like RTMP or HLS, RTMP is the base protocol for Facebook and YouTube live streaming, for example. Yeah, HLS creates an HTTPS web link of the live stream. So the target of this is actually to give you, with fewer devices, much different and more destinations at the same time where you can bring the content to. Besides that, Matrox 6000 in particular supports 2 or 4 HDMI inputs into the devices. So you even have a multi-channel capacity where we even allow you also to do composites in the purpose-built kind of concept that I mentioned before, where you have a 2x2 or a picture-in-picture as a base setting that you are sending out as a stream like this. And we do this compositing on the sending side as well as on the decoding side. Yeah. Last but not least, these also record at the same time. So we really speak about highest density integrated AV over IP / streaming in one box. So a very flexible utility. So and to explain briefly what you see here, so this is the pass-through of our encoder. Then this is the decoded output. You see it's a pretty low latency because we can create a low latency mode between our devices. And then we also show the Matrox first steps into interoperability, as H.264 is a very popular codec. There are compute modules out there that can decode our stream, just like VLC as well. So here we show a sharp neck, or now it's sharp only, a sharp display with an OPS compute module, a Raspberry Pi module that decodes the same stream as our own decoder, yeah, which also explains a little bit the differences in latency and color quality. Yeah, but that is the Matrox portfolio, H.264, H.265 encoding, decoding, again in a high compression mechanism in a 1 gigabit infrastructure. As we move along, I will change corners to my IP mix and SMPTE 2110 and other KVM, other AV over IP solution in here. Yes. So opposite to H.264 or codec-based AV over IP, as I always say, like the chip defines what you are allowed to do, we now move into open standards of AV over IP, of media transport over IP, and particularly IP mix and SMPTE 2110. As a short introduction into those specs, SMPTE 2110 was implemented in 2017 by the Society of Motion, Television and Picture Engineers. So it comes from the broadcast side, and it was made so that broadcasters could reach interoperability between their broadcast cameras, their video mixer, their vision mixers, etc., etc. And as we meet most of the signal as SDI in broadcast, it's very much focused on SDI signaling, also when it comes to the synchronization of the signal in the network. So yes, AV, of course, Pro AV was also starting looking into having something similar, but of course has different requirements. Because in AV over IP for corporate solutions and you know, in normal office meeting spaces, etc., you typically have no SDI. You have HDMI. You have bring your own device with Mac laptops and PCs and whatever you can think of. Maybe some combinations with SDI, but HDMI is the main signal we need to handle. And with HDMI, there comes HTTP content protection. There comes EDID, like resolution handling. We meet much wider aspect ratios and resolutions with HDMI than we meet with SDI. Hence, IPMix made its way into the world. Yeah, and the idea was actually, as there's a little overlap in brands in the alliances. So AIMS alliance is responsible for the IPMix standard, and SMPTE is responsible for the SMPTE standard. There's an overlap of companies in both alliances, and they did not reinvent the wheel new. So they just actually used the way how SMPTE 2110 describes the media transport as a spec and reused it in IPMX and added additional things that are needed for AV. Yeah, like synchronization. Yeah, IPMX has an own synchronization mechanism and doesn't require high-end network infrastructure to have a fully synchronized video. IPMX, as we speak, broadcast 80% uncompressed, 20% compressed video. In Pro AV, we speak 80% compressed and 20% uncompressed potentially. So an IPMX codec becomes an option, yeah, giving you the choice to do uncompressed media transport, but as well pick and choose between different codecs according to your need. Do you need light compression? Still good quality. There's the JPEG XS codec or the Pro AV codec that Matrox provides. Upcoming is H.264 and H.265 as high compression codecs under the IPMX hood. So now you may understand my answer to Adam when I said, like, does DVW understand IPMX? Not yet, because H.265 is not yet an IPMix, but Matrox will at ISE actually show the first products. Yeah, but on the other hand, when there's more products coming with H.265, then we already have that combination as well. But that should be enough about the standards, unless Adam or someone of you would like to know a bit more and has a question, then I would briefly like to explain what you see on this station here.
Yeah, so from my side, I will just put yet another question to our audience about key factors in terms of transmitting audio-video signal through the network. What are they most important factors to consider for our customers? Like technology, price, reliability, functions alongside stream, software, warranty. So you can continue, Katrin, and the question is already on the
Perfect.
attendees.
Yes, wonderful. So what we have here is a media player that gives us two HDMI feeds, and we are looping them through two senders that of the Convert IP series. I should say that as well. So Convert IP as a product is SDI, HDMI, and HDBaseD conversion. Yeah, and here in this case, we use our HDMI. And on this side, you see we are using JPEG XS as a codec. So these two units send a compressed video feed of these two video signals into the network. And at the same time, we are passing it through to two uncompressed senders, which you see we are using here 10 gigabit uncompressed feed to actually show you a realistic scenario of a mixed workflow. Yeah, from these senders, we actually go to the middle screens where we show the pass-through again, which is when you're in the live stream, it may not be that nicely visible, but when you visit us, which you are welcome to do, you will actually see, you can really compare the timing between sending to a compressed receiver versus sending to an uncompressed receiver. Yeah. And what I mean with this mixed network setups, I mentioned now with IPMix codec becomes an option. So what if you have a theater as one example, where you have a conductor pit where the orchestrator stands and the screen in the last row for the last musicians still needs to show the the movement in as little latency as possible, because if not, we will have an off-sync music, right? So in these cases, theaters very often use uncompressed media transport, if not classic SDI to start with, where most theaters are right now, but there's a paradigm shift happening at the moment. But at the same time, in theaters, you see that there's a lot of screens in the curtains, in the wardrobes for the artists, to the lobby house, to the front of the house where they have signage and they want to show some part of the place and so on. So classic signal distribution with copper cable. So before, they needed to use this product, which is 1 gig for this workflow, and this product or SDI for the conductor pit. IPMX as one option gives them now the possibility to do everything in the same infrastructure and with the same hardware, because our units, for particularly those ones that are equipped with a fiber connector, they can actually enable compressed streams as well as stream uncompressed. And in a simplistic scenario, you can imagine that you have one sender doing 4K 60 compressed in 1 gigabit, and you could have that same box, physical box, doing full HD 10 gigabit uncompressed to the switch, yeah, and Netgear or Nevion, I don't know if they have the combination with fiber and copper. Yeah, some switch brands already support that possibility to combine 10 or 25 together with 1 gig. So from there, you actually can stream to very flexible receivers, which could be again either the same box that actually toggles between automatically what it gets. Yeah, so, and that is the benefit of IPMX, that you can now start mixing workflows according to the needs, be it latency, be it quality, be it the need for compression and the available switches that you have in your infrastructure. So it definitely gives you more flexibility. And as we see, you know, we lack people, of course, to support, like AV technicians are like hot potatoes, hard to get. So if you have the same concept for your house, you actually need also less people, or less people can, because it's the same concept. Yeah, and that is one of the ideas I like about Convert IP, and I like about IPMX. Besides the fact that this is an investment in the future, because if you think, EDID is an open standard as well. So EDID, the display identification data, you find it on Sharp displays, Sony, Samsung, you name the brand. Yeah, it has the same mechanism of telling the GPU, no matter if it is NVIDIA or AMD, what kind of resolution to give. This is the same idea here. Every device that supports IPMX is able to talk to each other. Yeah, and more brands are joining this interoperability, and EDID started 20 years ago. It's still there. Now we have 8K, which no one thought about in 20 years before, right? So IPMX is supposed to stay. And what we already hear from customers, because Convert IP is shipping now the 3rd year, yeah, and the additions and features that we have added to existing boxes makes customers very happy, because they really understood, okay, they invested in the hardware, they invested in open standard, and now they have a journey where they can easily scale, upgrade with new features as they are introduced into the specifications. Yeah. So while IPMX is the spec of devices talking to each other, there's also, of course, the universal remote control needed that switches the different brands on and off and lets them talk to each other. So, and here, of course, control systems come into play. And Matrox, of course, has APIs to all their devices. If you would like to integrate it with Kramer, like Modulit provides, or Qsys, Crestron, yeah, you name the usual suspects. But there is also, because of the interoperability, the need for an open standard routing application and mechanism. And this is called NMOS. And Matrox offers an NMOS routing with a little pre-installed server, and the possibility to actually browse into the server through the IP address, and then to see the devices in the network that support IPMX and SMPTE 2110. And I would like to briefly show this in a second, that you see that. But before I move there, I would like to give a quick glance to a last IP product that we have here, that I already also mentioned as a bridge between the different Matrox worlds. So Matrox Vion, brand new IP gateway hardware, exists in two flavors. Vion NX, as the name may tell, it's network conversion only. Vion EX includes an expansion card and makes it an encoder, decoder, transcoder with HDMI and SDI support. But in terms of IP, you see that we are starting to support more and more things on the same hardware. So in terms of IP, we actually support H.264, H.265, NDI, IPMX with JPEG-XS compression, as well as SMPTE 2110 with JPEG-XS compression. And either with the HDMI or SDI, you can encode, transcode, decode back and forth, or within IP, we could take our MAVX, convert it into IPMix to show it on our convert IP, or we can collect a convert IP and show it on our video wall as a bridge product. Yeah, which, you know, when you remember when I showed the synchronization video, this was actually a feed from the convert IP that we used on the wall that has been converted by the Vion as a process. Yes, but let's talk about NMOS. Interesting for the for the NMOS part. So I mentioned Matrox Conduct IP as an open standard routing mechanism. Yeah, and I'm not going too deeply into this, but I would like to explain the concept. So there is a device bin that you see down here with a lot of devices, yeah, where you now realize already inside Matrox, there's the KVM, there's the Vion. We even have a Dante device in our workflow, Dante audio device in workflow, and so on. So the mechanism of NMOS is to auto-detect and discover SMPTE 2110 or IPMX-based devices. And then from here, you can make them part of a routing mechanism. Yeah, so we have created different rooms with different devices in it. So in every room basically creates a switching panel, which may appear very like similar to what you know from Stream Deck or companion buttons and so on. So this is and even a live switching kind of utility that is used in a lot of broadcast environments, but it's becoming very popular for theaters and convention centers as well because of the interoperability. Yeah, just to mention, like, for example, the current theater we're working in Norway, they use Panasonic PDZ cameras, so that supports SMPTE 2110 JPEG-XS. So that camera automatically appears here and is part of the workflow and can be combined with a convert IP with no further ado. Yeah. So, and that API to NMOS is available on GitHub. So it's also developed by an alliance called AMVA, or an organization called AMVA. So everything what I told you now, except for the products, is not Matrox. So all the specifications, the ideas, the features that make it into specifications are the thinking of an alliance and of multiple, even competitors, which is sometimes a little tricky thing, that actually work on those things. And now I just realized, looking at the picture-in-picture, I forgot one little item that I should not forget, because I like to call it my baby. We have a special flavor of the convert IP. So we spoke about OPS, and we spoke about slide-in modules for displays and so on. And something becoming very popular these days as well is SDM. SDM is an Intel standard that is actually a module that you can slide into a display. And you see this here with our Panasonic display, which actually, by the connection inside the display, it's like an internal HDMI or DisplayPort connection to the display. So you have picture as soon as the component is inside the screen, yeah. And then you only put a fiber or network cable into it, because the Convert IP SDM supports fiber as well as copper on the same hardware. So you pick and choose again according to the flexibility that I mentioned, what you would like to show on this receiver type. So the SDM is a very nice integrated device, particularly again if we think about theaters where the screens are hanging between the curtains, or if you think about immersive presentations with multiple projectors, where there's actually another add-on that I would like to mention coming into play, redundancy and the possibility of daisy chaining. So IPMX carries a redundancy standard, which is, I think, unique to solutions. So in that, with Matrox combined possibility of daisy chaining between the different devices is again a nice facilitation of rigging and installations in certain spaces like theaters, like convention centers, and so on, and live events and rental events and so on. Yeah, but that's, I think, the tour about IPMX and Convert IP and the Vion IP gateway. Is there questions left to open standards, Convert IP, and things like this?
I don't see any at this moment, so we can continue.
All right, then we move to the last corner of our room and hit almost the end of the session. So back here, we have a little visual. So, and I took my perfect bridge from immersive presentations and these type of things to actually come to our little artistic corner here. So in the artistic corner is represented by the Matrox Quartet to Go. So on Quartet to Go is a very flexible and versatile product, being from the beginning a simple splitter. So we actually collect a 4K signal into it. We split it to 4 Full HD. So we could, for example, use it with a simple signage player and create a 2x2 small video wall from it with native resolution to the individual screens. But we also have some logic in it that allows us, with the help of a free of charge software called Powerwall Plus, to create these artistic configurations like you see here. Because besides the 4K native capture or native input we can do, we can actually upscale what we are collecting in terms of resolution to up to 8K resolution. Yeah, and then we can even freely rotate and place the displays on this background. I sometimes compare it with Christmas cookie cutting as we are moving into the Christmas time. It's a nice comparison again. So you basically place the displays on this 8K background and select for the display the area that they are supposed to be represented. And we are not only scalable resolution-wise on the input side, we are also on the output side. And maybe to assume Adam's question, is it supported with LED as well? Yes, exactly. Particularly for like strips, LED strips that we meet very often now in public places. We can do this custom output resolution, long and stretched, for example. Or as we can also compensate for the display frame, yeah, or we can create gaps between the picture. It's very popular with projectors because we can actually merge the image for the projection, and then the projector would handle the light adjustment across this. So we see it's been used in the traveling art gallery in Spain, for example, where there was several projectors that needed to be blended across the walkway for the audience and so on. So for this, it's a very popular product, and it also helps with extension because you can basically go a long line from the media server to those output boxes and then set them close to the projector. So again, it's helping here the facilitation. Yeah, we have a very nice installation, for example, at Munch Museum with it in Oslo. where they even do the combination of IPMX with the Quartet-to-Go. So they have media servers there where they collect, for example, 3,400 resolution. Yeah, again, IPMX doesn't really care because it doesn't have limitations in aspect ratios. So, and then they use the convert IP to send it from the media server in the basement to the fourth floor over IP. And then they have the convert IP connected to Quartet-to-Go to run 4 full HD projectors in a wide curved screen where they promote a Norwegian pop artist. Yeah, as one actual use case that I just visited last week. Yes, but this is Quartet-to-Go. That's why I still like to talk about it. It's lightweight, it's passively cooled. It's also well priced, I think, for the capacity it can do. And it's a nice complementary product for the visual part where Matrox, I'm always saying I'm the video girl when I speak to AV people. And we also give you some nice visual utilities to do enhanced presentations and things like this. Yeah, but this would be it from the Matrox portfolio. And I will move back maybe to the center view to see if there's more questions. Turning around my
So
laptop.
yes, actually we have some questions. First is about the IPMX standard. Where do you see the most opportunities for it? Which type of the markets?
It is developing, and this is the exciting part of it, because initially I started to go after the environments where people looked into 10 gigabit SDVoE based solutions because they wanted to have less latency than 1 gigabit solutions. And from there, I grow particularly with the flexibility, but I also converted some of those people to go compressed because of the super performant codecs that IPMX is offering. Now we are starting in convention centers, like besides these live stages and environments, we're starting to see convention centers getting interested in it because they also have, in the hotels, flex meeting rooms, and IP distribution makes it just so super simple. If they have 5 projectors and once all the 5 need to show the same picture, or at once they need to show 5 different pictures, IP is just making it very, very easy. And with the fast switching and the fast interaction that IPMX offers, it's becoming popular. Something cooking, I would say, not yet full to light, I would say, is what we call media hubs, corporate media hubs. So what I mean with that is corporate companies that have an in-house broadcast studio, but also auditoriums and meeting rooms. And here we actually meet some of the arguments I mentioned before. Typically, it was Crestron in the meeting room, and then it was something else in the broadcast environment. Now, with moving SMPTE 2110, they can still have the SMPTE 2110 in the broadcast with all what broadcast needs, but the combination with IPMX to give compression is now like saying, oh, all right, this is now the same concept going to my meeting rooms, to my auditoriums. And even though I do compressed AV signal distribution in the meeting rooms, I can actually feed it back to the corporate studio for production, for using it into some live productions that they do. So that combination is becoming popular, I would say. Yeah, so I mean, there was a LinkedIn picture live last Friday, Novo Nordisk, to mention as one example, where the commissioning is happening just now. They are, for example, a customer that has decided, okay, we have that amount of IT and AV people in our house, and why do we need to handle different brands if we can actually have, or different technologies, if there's a technology out there that can do it in a similar and comparable mechanism.
Yeah. So the next question arises is, how do you compare? Because we have now maybe not several, but at least few important codecs becoming or popular in AV industry. And if you're looking for something which is like a top tier premium one, it's actually SDVOE because of the quality and no latency at all. And the IPMX is comparable, right? Or not? So how to compare those two standards?
I would say we are better, of course. No, the thing is that, for us, it starts with 444 color space. Yeah, so we support the highest possible color space for RGB as well as for YUV signaling to start with. And the SDVOE uses software-defined video, so it's a light compression mechanism that requires you to stick with 10 gig. We did the shootout. Maybe this is the best thing because then it's not me claiming something. We actually did the shootout in Sweden, where it was a row of tables, Extron, NAV, Crestron. It was Aurora's SDVOE solutions. It was Dante Ultra AV. It was NDI, and it was Matrox. So, and the university wanted us to show our compressed solutions. So I chose JPEG XS as an option. And we won in quality. And my biggest fear, and here I'm also very honest, because JPEG XS comes from the broadcast side. And the reason why Matrox also suggested Pro AV codec to the alliance, which didn't work out, unfortunately, was the JPEG XS video is not an optimized codec for desktop content. Yeah, so I did run the convert IP at 1.3, 1.5 megabit per second because the RJ45 on our devices supports 2.5 gig. And I was a bit afraid what would be the reaction to that from the customers. And they said like, oh, you can scale. Yes, you can actually scale the network bit rate according to the quality needs you have. It doesn't impact latency because JPEG XS by specification is a subframe latency. Yeah, but the quality was just perfect. And I say like, well, there's not a single computer shipping with 1 gigabit network connection anymore. So 2.5 is standard. So for us, this is fine that we are not necessarily when we do 4K 6444 within a 1 gig scenario. For full HD, we are, no problem with that. But we won. This was the result of the customers that were there, universities in this case, the video technicians of several Swedish universities, and maybe, I don't need to comment any more on this.
Okay, understand. So is the IPMX going to replace other standard, which is H.264 to 65?
I think they will coexist because, as I said initially, we have these three segments and have zero latency, uncompressed, raw. Then we have light compression, where SDVOE would play in, as well as the JPEG XS and the Pro AV codec from Matrox. And then we have the need for high compression still. So, and this is where H.265, I would see really taking over time because of its higher efficiency compared to H.264, but they will coexist.
Okay.
But they will definitely coexist. So, and I would recommend you to come to the Matrox booth at ISE. We are showing there the first IPMX H.265 implementation. So native H.265 in IPMX. So there's something new coming up at ISE.
Okay, I have one last question, which is about interoperability of your solutions. It's an easy question, but if you can remind us, how do they work? Like, can we combine different products from your portfolio to make the system more complete? Like some encoders with specific decoders, or even video wall appliances, or maybe Mura cards with some kind of decoders. How does it work?
Yeah, Adam, perfect question. Because what I haven't mentioned is the IP ecosystem based on H.265, based on IPMix now. I spoke about XDO and the Mura and so on. But we have now an IP mix-based ecosystem with Avio KVM and Convert IP and Vion. Yeah, so you can already seamlessly combine. I could grab a Convert IP sender feed and show it on my Avio receiver. Respectively, I could grab from a KVM Avio to sender and send it to the Convert IP receiver. So within Matrox, the interoperability across different, I would say, nature of products is already there. But going outside of Matrox, yeah, we have Panasonic as a favorite example, supporting on the Kairos Vision Mixer, SMPTE 2110 and IP Mix, but also on their PTZ camera line. We have Epson joining. We have TV1 joining. We have more and more media servers like Analog Way, Pixera, Dataton that are natively doing SMPTE 2110 or IP Mix out of their media server. We have on the LED controller side, also one of your favorite topics, all major LED controller brands support SMPTE 2110 natively. And some of them also have IP Mix now, like Colorlight, Novastar SMPTE only, Prompton. Yeah. So, and here the idea is really remove boxes. Yeah. It's like, of course, you can use a Matrox sender to collect your Mac PC to stream it directly to a Novastar LED controller. That is the idea, that no HDMI, no SDI will exist at some point, whenever in the future. It's everything in the network and you handle everything through the network, no matter what is your endpoint or if you have an endpoint at all.
Okay, thank you. And the last question coming from me, actually, it's about the integration and the cooperation you have with the TV1, because it's also the brand we have in our offer. And I'm interested because the Calico Pro video processor from them, it's actually very powerful device. Do you have like a little bit more insights about how the cooperation works here? What's the
We,
key point?
we don't have a cooperation with them. They are part of the alliance and
Mm-hmm.
they develop their own IP Mix implementation.
Okay.
So I'm not even sure. Matrox sometimes helps customers getting there. Of course, also OEM products, but in this case, it's their own implementation. But it actually brings me to an important point. Again, thank you, Adam, for filling in my gaps sometimes, because you may wonder now. So how do you guarantee interoperability? Yeah,
Mm-hmm.
and that is something coming up at ISE 2025 as well. There will be, I would call it a batch program. Yeah. So fully IP mix ready, partially IP mix ready, something like this. Because the Alliance created features segmentation saying like this is a must feature to be IP mix compliant. This is a maybe feature. And this can still be a manufacturer individual feature. Yeah. And
Mm-hmm.
that will be published so that every customer actually sees, all right, here's base compatibility and here it may go apart from each other. There's a nice podcast I can recommend, Matrox podcast about this program as an introduction on Spotify. So I can also send a link to that if you want to listen
Please
to
send it to
this.
me and I will share with our attendees after the webinar.
Mm-hmm. Yes.
Okay. And the last question, which is actually a question to our audience, is about most interesting solutions from Matrox.
Oh yeah, this would be
So I
cool
shared the
to know.
question with our partners. Let's gather some responses. From my side, I would also like to emphasize that the Matrox is here in our offer. You can find it on our website. You can also find demo products in our offices. So if you're keen to, for example, test the distributed video wall appliance, which is quite nice solution, I can say, especially working together with Mavex, we have this kind of demo set available for our partners. So just contact me or contact your key account manager at Modulit, and we will do our best to deliver to you. Like I said, you can test on your side. Yeah. Okay, we are still gathering some Answers. Let me check if there are any more questions coming. No. No, no. Okay, few additional seconds. I can see right now that the most interesting part for our partners is actually, I can share it. It's about AV over IP and MEVEX. And the second one, it's a video wall appliance and Vion. So yeah, actually we're talking about combining all different solutions into big AV over IP network, which allows us to show the image, properly on the video walls or just the displays all across the installation site.
Very nice.
Okay.
That's very nice to hear. Yeah. Hmm.
Okay, so there is no other questions, so we are getting closer to the end. So Katrin, thank you for this for this journey all around your video lab. It's really interesting. It's I need to say it's not the first time I'm visiting it virtually, but every time it's yeah, the best way to present your products. So thank you for that.
Thank you so much, Adam, for setting everything up, and thank you, dear audience, for listening. And yeah, feel free to reach out for more
Yeah.
questions, and we're happy to help you get growing in AVoIP together with Modulit.
Yeah, for those who are a little bit busy during our training, remember that the video recording will be shared with you. So don't worry, you can always watch it later. Okay, thank you. So I wish you, Katrin, the very best week, and to
Thank
our
you.
audience, the same. Have a good week, everybody.
All right. Thank you so much.